Hey everybody. So we just talked about our key features, we talked about transformations, we talked about all these different things with domain and range, all the good stuff when it came to functions. So now this section here is talking about applying all the information that we know, or just parts of those information that we know, to be able to do it to real life situations. And again, the most important part that we must understand is math is not just numbers that we just write on really quickly and then compute and then find some value and then we're done. No, math is real life. Math takes what's in the world, it takes what's in real life, and well, pretty much takes the numbers and puts them into a real life thing, and then it makes sense to like what's going on, and we can use math in the world around us, and not just we just did a number and it made sense at that point, but it makes sense to what's really happening around us. That's what math is all about. All right, so the part that we're going to deal with right now is optimization. And if you plan on going to calculus, we would do optimization again, but that way we would actually, with calculus, we'll actually be dealing with things called derivatives. And so here we're going to do it without going the calculus way. We're going to do it the pre-cal way. So first off, optimization, let's go. There we go, sorry. Optimization is the process of making a quantity as large or as small as possible. Let me pull it down some so you can see it. So optimization again is the process of making a quantity as large or as small as possible. And what I want you to think about is when we're talking about things as large or as small as possible, think about what we've talked about with our key features. One thing was talking about large, or the highest point or lowest point, was talking about our max and our mins. So here, when we start talking about like our large part, we're talking about like our maximums. When we start talking about our low part, we're talking about our minimums. So when we start going to like our graphs and all that stuff that deals with the max and our mins, we're going to be using that part, the graphing part, to help us to figure out what is the max or mins. But the great thing I love about optimization is not only are these word problems, not only are they real life things, so that it makes sense of like why we do the math in the first place, but it also talks about like how companies can say, okay, we want to figure out what is the smallest amount of resources that we can use to create this object so that we can sell it to make the maximum product, or make maximum value from it. Or what is the largest amount of trees that we can have here so that we can make sure that we get the whole area covered the best way and cover the most area. Those type of things that companies literally do. They literally actually think about, and they actually have somebody actually doing the math behind the scenes to figure out this is what would be the best thing to do. This would cost the least amount of money. This would cost the most amount of money. This would be like the best for everybody. This is what all optimization is all about. Real life stuff. I love it. All right, so I'm going to go ahead and jump over actually another page that I originally would have you guys do. And we're going to come here to our steps for optimization. So here, our steps to optimization, there's 4 of them. So the first step is, once you've actually read the problem and you kind of gauge what's going on, you say, okay, let's draw a picture. Let's draw a picture to say, okay, this part's here, and then we label it. So if it's a quantity that we know, we're going to put the number there. If it's a quantity that we don't know, we put a variable in that spot. And that's what it says up here. So label the quantities in the picture, and it should say in the picture. Sorry, it's a gray box right there. So here, draw the picture, label the quantities in the picture that you think might be important. And then use numbers for the ones that you know and the variables for the ones that you don't know. So in other words, those sides or those parts of the square, rectangle, whatever we're dealing with at that point, if you know what the number is, you put the number there. If you don't know what it is, put a variable in that spot. Makes sense? All right, step 2 says now write a formula for the quantity you want to optimize. So are we trying to find the area? Are we trying to find the max area? Are we trying to find the min area? Are we trying to find the max volume? Like, what are we trying to find? What are we trying to find? The max or min of? And whatever that is, we write a formula for that. That's step 2. All right, step 3. Step 3 says, okay, so now that we have that formula, we have to solve it out somehow. We have to be able to put it into a calculator or put it into something to be able to figure out your max and your min for it. But when we do that, only way to be able to put it into the equation or put the equation into like y equals in a graphing calculator, TI-84 or 83, whatever you're using, or even in Desmos, you have to have one variable. You can't have x squared plus y squared equals a number. You actually have to have it in one variable. And so what would be the best thing to do is try to see, okay, is there any other information inside of this actual problem that will help me to be able to change the y over to something with x? So hopefully there's enough information that would actually cause you to have to, like, for example, find the perimeter of some sort, and then you can actually write the perimeter in x and y, and then change things around and solve for y, and you can change the y in the original problem so that it has nothing but x's. So in other words, what we're saying here is, if there's more than one variable, use the other information in that problem to rewrite the formula so that you only have one variable in use. So you cannot have x and y to solve out the problem. You have to have nothing but x's there. So, or you can't have x and y's. You can have just y's there. So it's up to you with that part, but you have to have one variable when it comes to this step. Because that way we can go ahead and put in the calculator, solve it out, and we can do step 4, which is use the formula you found in step 3 to find the maximum and minimum value of the quantity you want to optimize. And again, that means that we are going to have to find the max and min, which means we're graphing it. Max and min. Step 4. All right, so we're going to go to a problem now, example 1, where we're going to go through these parts and actually understand like kind of like what's going on. All right, cool.